We met the variance during the very first part of this course. It was the oddball parameter we described as spreadness and scrunchness. It told us how uniform the data were, how alike they were. It said that if we were looking at ages of people, we would expect the ages in the first grade class to have a small variance, and the ages in the whole city would have a larger variance because it included all the children and all the retirees and everybody else in between. The variance was found to be the foundation of all of our hypothesis tests and our confidence intervals. Our confidence intervals were always plus or minus something, and the standard deviation, read variance, was always determining that something. The standard deviation, square root of the variance, was the bottom term in all of our hypothesis test formulas. We have been, perhaps, taking the variance a bit, by implication, the standard deviation, for granted. In order to test a hypothesis using the F distribution, we need to learn how the F table works. We need to know this because we need the critical values to determine if the calculated F values fall in the tail. In this way, hypothesis tests using the F distribution work exactly like any other hypothesis test. The F distribution is created as the ratio of two chi-squared distributions. The F distribution looks like a chi-squared distribution. It is skewed, and it changes shape as the degrees of freedom change, also like the chi-squared distribution. Remembering that the chi-squared distribution has degrees of freedom, and now knowing that the F distribution is a ratio of two chi-squared distributions, we see that the F distribution must have two sets of degrees of freedom, one for the chi-squared distribution in the numerator, and one for the chi-squared distribution in the denominator. To determine the critical values for our statistical test, we find F sub alpha, dF, meaning degrees of freedom 1, and dF, degrees of freedom 2, in the F distribution table. The two different degrees of freedom, one associated with the numerator, dF1, and one associated with the denominator, dF2. The degrees of freedom in the numerator is N1 minus 1, where N1 is the sample size for group 1, and degrees of freedom in the denominator is N2 minus 1, where N2 is the sample size for group 2. F alpha, dF1, dF2 will give the critical value in the upper end of the F distribution. As an example, imagine that we have sampled two groups, and we want to know if they have different variances. And we want to have a 90% level of confidence. If group 1 has a sample size of 6, N1 equals 6, and group 2 has a sample size of 13, N2 equals 13, we can calculate the degrees of freedom by subtracting 1 from each sample size. This gives us the degrees of freedom for the numerator and the degrees of freedom for the denominator. We draw the F distribution and mark the alpha level in each tail. For the right-hand tail, the upper tail, we look up F critical value by going to 0.05 F distribution table and looking for 5 degrees of freedom across the top row, dF1, and then going down until 12 degrees of freedom at dF2. We find 3.11 and mark this on the graph. This gives us the critical value for the right-hand tail at the upper end of the distribution. Like the chi-square distribution, the F distribution is skewed, so we have to take a second step to get the critical value for the lower end of the distribution, or the left-hand tail. To find the critical value for the lower end of the distribution, reverse the degrees of freedom and divide the F value we find in the table into 1. By reverse the degrees of freedom, this means to change the order of which one is in the numerator and which one is in the denominator. In this example, we look up 13 degrees of freedom across the top row now, and go down to 5 and read 4.68. We then divide this into 1 and get 0.214. This is the critical value for the lower tail. The two formulas for finding the critical values for the F distribution are these. I know this seems a bit crazy, but this is how the F distribution is constructed. More on this later in the next unit.